Good afternoon, students. From the previous class, we started with the semiconductors, right? On that day, we are seeing the conductivity and resistivity of metals, insulators, and semiconductors. Right. Now, we can go for the very important thing, that is the energy bands in solids. Okay. So solids la energy bands எப்படி இருக்கும் அப்படின்றதுதான் we have to see. Okay. Right. So energy bands, which is nothing but it is a sitting place of electrons and holes. அப்படின்னு வச்சுக்கலாம். Right? Right. So here I just draw the band. Okay. Energy bands we are taking. Okay. For the lowest one, we are represented as EV. Okay. So this is the lowest state. And here, this in this state, it is filled by electrons. Okay. So here, EV is the valenced band. Okay. Valence band. So the lowest state, we are named it as a EV. And one more state is there, that is EC. Okay. It is nothing but conduction band. Okay. So in that conduction band, it is the highest state. So here, lowest state, it is having a highest state. Right? Okay. So the energy band, the lowest state, we are represented as EV. And the highest state is represented as EC. Okay. EV, which is nothing but it is the valenced band. Valence band. And EC, which is nothing but it is the conduction band. Okay. So here it is a lowest state in soliyache. Okay. So energy will be minimum or maximum. Enna irkalam. Yes, pannunga paakalam. What will be the energy in lowest state? அதாவது உங்களுக்கு சாப்பாடே கொடுக்கல அப்படின்னா the energy will be more or less. So simply like that, electrons are in a rest condition. Okay. Electrons are here if it is in a rest condition. Yes, very good. So for the lowest state, the energy value is minimum. So here it is a minimum energy. Okay. So for minimum energy, conduction band light is having higher energy, right? The energy will be maximum in conduction band, right? So this is the concept. And one more thing, here the distance between, that is the difference between, okay, so the difference between energy band and conduction band, we are named it as a EG. Okay, so here, which is nothing but it is EG. EG represented as a gap. Okay, so here we are deal with the energy band, right? So Eg, which is nothing but energy band gap. Okay. Right. Next one. Some more points about the Eg. So up to this clear, what does mean by Eg, which is nothing but energy band gap. So here Eg, which is nothing but energy band gap. So Eg, which is nothing but it is a difference between valence band and conduction band. Right. Now the electrons which is in a valence band, we are named it as a valence electrons. Valence electrons. So let us now tell me what is the electrons which is in a conduction band. We are named it as a conduction band electrons. Similarly, it is a comment பண்ணுங்க பார்க்கலாம். Yes, very good. It is the conduction electrons. Conduction band electrons, we are named it as a conduction electrons. Right. Right. So the Eg value is either smaller irkalam, either it may be a small or large, or sometime it may be 0. Okay. So the energy band gap vachida we can classify the materials. Okay. So energy band gap oda value sometimes 0 va irundha enna, it is a large irundha enna, small irundha enna அப்படின்றதுதான் we can go for the next. Okay. Suppose இந்த ரெண்டு energy gap overlap ஆகுது அப்படினாவே எந்த ரெண்டு பேண்டும் it should be combined. What will happens when the two bands, valence band and conduction band, it should be overlaps, means what will be the energy band gap value, that is EG value. You may guess. So here, valence band is there, and here conduction band is there. Okay, suppose, so here we have to mention it some more color. So here it is a conduction band. Okay, so let us now, it is overlapping means coming together. So it is overlaps. So it is overlaps means what it means, there is no energy gap. Okay, so here this part we can name it as EG, and here there is no energy band gap. Okay, so both EV and here it is EC, right? Here it is a EC. So both of them is overlaps. Overlaps, it is coming together. Okay, combined together. So automatically the EG value, it should be equal to 0. Okay, so this is for this case, it should be occurs in metals. Okay, it is clear. For metals, EG value is equal to 0. Okay, so keep in mind that. So this is the first one. Then second one, it is insulators. Okay, so this insulator la, the gap will be larger. Okay, larger energy gap. So here it is EV, and here it is EC. Okay, so energy gap EG will be large, larger energy gap. So that the value பார்த்தோம் அப்படின்னா it is greater than 3 electron volt. 3 electron voltக்கு மேல இருக்கிற மெட்டீரியல்ஸ் எல்லாமே என்னவா இருக்கும், இன்சுலேட்டர்ஸா இருக்கும். ஓகே, இப்போ சே ஃபார் எக்ஸாம்பிள் 5 எலக்ட்ரான் வோல்ட்ஸ் இருக்கிறது என்ன டைப் ஆஃப் மெட்டீரியல் அப்படின்றத கேட்கலாம். 4 ஆப்ஷன்ஸ் கொடுத்து எய்தர் இட் ஷுட் பி a metal, insulator or semiconductor or none of this அப்படின்னு கேட்டாங்கன்னா you may think it of the value ranges. Okay, value ranges நீங்க மைண்ட்ல வச்சுட்டு you have to mark the correct answer. Okay, next semiconductors. Okay, semiconductors la the EG gap it will be smallest gap. When we are comparing to the insulator, the energy gap value for semiconductor is small. Here it is a small gap. Okay, so small gap abdina, here greater than 3 abdina, it is a insulator. Here it is a less than 3 electron volt. So less than 3 electron volt irundhathu abdina, it is semiconductor. Okay, so Eg represented as a energy band gap. Okay, so the energy band gap we can classify into 3 types of materials, that is metals, insulators, and semiconductors. So in the மூணு நம்ம already பார்த்திருக்கோம், right? So for metals, Eg value, it should be equal to 0. And here it is Eg value greater than 3 electron volt. And here it is Eg value, which is less than 3 electron volt. Okay. Right. Up to this clear? Yes. Okay. So let us now go for the related questions. Okay. So you just to try it. When a semiconductor is heated, resistance, its resistance becomes what? Okay. So it is A decreases and B increases and C it remains unchanged. And 4, there's nothing to definite. So let us try this one. When you heated the semiconducting material, the resistance value, it will be decreases or increases. Yes, very good. It is decreases. So temperature increase the resistance or values namakku குறைஞ்சிட்டே வரும், resistivity or values குறைஞ்சிட்டே வரும். Okay. So if you go and check it the resistivity value. Okay, go and check it the resistivity value of semiconductors. The semiconductors la parunga, it is the combinations of 10 power of rho is equal to 10 power of minus 5 to 10 power of 6 kuttupanga. Right? So the ranges, it should be positive to positive and negative. So for temperature either increase resistivity oda values namakku enna aite varum appadina, it is going to decreases. Okay, so in the applications la vachida for the wirings and all, we are make it a material that is a semiconducting materials. Okay, so nowadays the semiconductor chips, okay, So semiconductor chips, semiconductor nano wires, ellame they are constructed by using this methodology. So resistance or values decrease irundadu abdina the application it will be very more. Okay. Right. Next one, second question. In an insulation, the forbidden energy gap between valence band and conduction band is order of 1 mega electron volt and B it is 0.1 mega electron volt and C it is 1 electron volt and D it is 5 electron volt. Okay, so this is the question. So let us try this one. Yes. So here it is 5 electron volt, right? Then for the next one, which of the following material is the best conductor of electricity? Okay. So here they are provided the answers, that is platinum, and B it is gold, and C it is silicon, and D it is a copper. is the best conductor? Yes, it is that copper. So you are keep in mind that here gold is also metal. Okay, so both of them is a metals. So copper, gold. So if you are comparing the copper and gold, copper is the best conductor. We should keep in mind that one constant values, that is Eg value for silicon it is 0.7 electron volt, and for germanium it is 0. Sorry, it is for the silicon value will be maximum, that is 1.1 electron volt, and for germanium it is 0.7 electron volt. Okay. Ma'am, it is platinum and gold. Okay. Platinum and gold, both of them are metals. நம்ம யூஸ் பண்றோம் இல்லையா, it is a gold metal, and platinum is also a metal. Next one, types of semiconductors. So here we can have two types. One is intrinsic semiconductors, and other one is extrinsic. Okay, intrinsic semiconductors and extrinsic semiconductors. So let us go for the first one, intrinsic. So in this intrinsic, what is the speciality abdina? The number of electrons and holes, it will be equal. Number of electrons, which is equal to number of holes. ரெண்டுமே it should be in equal. இதுல both of them equal. Okay, so simply we are write it as a, here it is Ne and here it is NH. Okay, so electrons having a positive charge or negative charge? Yes, very good. It is a negative charge and automatically the holes will be a positive charge. Okay. So we keep in mind that electrons, it is a positive charge. Electrons, it is a negative charge. Negative, and holes, it is a positive. Okay. So in that, in intrinsic semiconductors, we are just introducing one more, that is out of Ne and NH, Ni is there. So Ni, which is nothing but number of intrinsic carrier concentration. Number of intrinsic carrier concentration. Okay. So for extra intrinsic, Ne and NH value, it should be equal. So similarly, Ni order values, it should be equal. So we keep in mind that Ni is equal to NH or Ne is equal to NH. இது மூணும் நம்மளுக்கு என்னவா இருக்கும்? It should be equal இருக்கும். Okay, so this is the first important point in the intrinsic semiconductors. Okay, next second point. So in the intrinsic semiconductors எல்லாமே mostly எப்படி இருக்கும் அப்படின்னா it is a pure இருக்கும். Okay, so pure semiconductors தான் இருக்கும். So it is a pure semiconductors. So pure semiconductors அப்படின்னாவே either it may be covered with only silicon or germanium. Silicon, mostly silicon or germanium is present in the intrinsic. Okay. So இது ஒரு silicon atoms அப்படின்னாவே இதை சுத்தி நம்மளுக்கு என்ன atoms ஆவே தான் இருக்கும். It is a silicon atoms ஆவே தான் இருக்கும். Okay. So it is a pure semiconductor. So where either combination some atoms, it should not be there, present there. Okay, so only the silicon atoms, it should be present there. So that only we are named it as it is a pure semiconductors. Where the type of atoms இது கூட combinationsல add ஆயிருக்காது. Only the thing silicon na silicon மட்டும்தான் present ஆயிருக்கும், or germanium அப்படின்னா germanium மட்டும்தான் present ஆயிருக்கும். அதோட combinations of groupingல. Okay. So this is our example. And here we can go for the bond. என்ன types of bond இருக்கும் அப்படின்னா mostly silicon and germanium make it a bond formation. So இப்ப சிலிக்கானும் ஜெர்மானியமும் bond formation பண்ணுது அப்படின்னா என்ன type of bonds இருக்கும் அப்படின்னா mostly intrinsicல it is a covalent bond. Covalent bond or valence band இருக்கும். It is a valence. So the bond formation either covalent bond or valence band இருக்கும். Okay, then one more point. So the flow of charge carriers, it will induces the current value. So the current value, which is a combination of என்னெல்லாம் இருக்கும்? It is a combination of இங்க intrinsic semiconductors, it is the combinations of இங்க நம்ம both the things எதை பத்தி தான் பார்த்துட்டு இருக்கோம்? It is the electrons and holes பத்தி தான் we are talk about. Okay, so it is the combinations of electron current plus the hole current. Okay, so the current value I E plus I H. Okay, right. So this is the fourth point. And fifth one, if you go for the temperature increases ஆகும்போது the resistivity ஓட values for semiconductors it is decreases அப்படின்ட்டு பார்த்தோம், ரைட்டா? So temperature increase ஆக semiconducting materials ஓட resistivity value it should be decreases. Okay, so at 0 Kelvin what will be the position of semiconductor? So at 0 Kelvin என்னவா இருக்கும்? You may guess. Either it should be increases or decreases, or it may be 0. என்னவா இருக்கும்? 0 Kelvin is there any conduction process? அங்க conduction process நடக்குமா? Yes, it is 0. Okay, nothing, it should be happened at 0 Kelvin. Okay, so here there is no conduction. There is no conduction in 0 Kelvin. Okay, so this is not a okay. Okay, so this is a 0 Kelvin. Okay, 0 Kelvin. Kelvin there is no conduction process. So 4 lines கொடுத்துட்டு when the conduction process it should be going to 0 when they are given. Okay, either 0 Kelvin, 0 degree Celsius, or 100 degree Celsius, or 100 Kelvin. Okay, 4 options இந்த மாதிரி இருக்கும். Okay, so on that time we are choosing 0 Kelvin. Okay, so this is the correct one. Next one, what about the ionization energy in intrinsic semiconductors? Okay, so here the next point is ionization energy in intrinsic semiconductors la eppadi irukum? Ionization energy for the same group of elements irukkalam. Okay, say for example carbon, silicon and germanium. Okay, carbon, silicon and germanium are same group of elements. So in the same group of elements we can target the carbon abdina. Carbon is having a highest ionization energy. Okay, highest ionization energy, but it is not a semiconductor. Yeah, abdina. Carbon from the valence band we are having how many electrons? Here the carbon oda atomic number it is 6, right? So for the energy band combinations So if you fill it the energy level orbits for the first one, it can be occupied by only 2 electrons, right? From the next ring, it is the occupation of 8 electrons, right? So here only 6, already 2 left. Okay, so what will be the remaining? It is 4. Okay, 1, 2, 3, 4. Okay, so the outermost shell we can call it as a balance. Outermost ringல present ஆயிருக்கிற electrons தான் என்னது valence electrons. So for the carbon, it having 4 valence electrons, right? Carbon having 4 electrons. So if ionization energy will be very high அப்படிங்கும்போது ionization energy means what அப்படின்னா, suppose if you are removing the electrons from the valence band, okay, remove பண்றோம் அப்படின்னா we have to spend it some energy. Okay, so if the only one atoms it should be present there in the outermost shell na, the energy of spending amount it will be minimum, right? So here there are 4 electrons. Okay, so the 4 electrons are there. So we have to supply a large amount of energy to remove the electrons from the outermost shell. Okay, so that only the carbon having highest ionization energy. Okay, so the highest ionization energy comparing to the silicon and germanium விட அதிகமா இருக்கனால, okay, it should be maximum when we are comparing to the silicon and germanium, carbon having highest ionization energy, so that it is not a semiconductor. So on the ionization properties, it should be minimum irundadu அப்படின்னா it will act like a semiconductor. Okay, so the ionization energy it will be maximum அப்படின்றதுனால கார்பனுக்கு கார்பன் என்னவா இல்ல, it is not a semiconductor. So here I have write it down, carbon is not a semiconductor. Okay, up to this clear? So the 6 important points we are discussed in the intrinsic. Yes. Next one, extrinsic. Semiconductor. So intrinsic semiconductors are impurity semiconductors. Okay. So let us know what is meant by that impurity. Okay. We can go for one example. If you take it a milk, right? So if you look it into the milk, it should be in a white color and it should be in a pure form, right? So this is the example of intrinsic. Okay, intrinsic semiconductor likewise. Okay, milk வந்து does not be a semiconductor னு எடுக்க கூடாது. For example I have to tell. Okay, so அந்த மாதிரி it is pure இருக்கிறது. Okay, only one elements it should be surrounded by the other elements. Silicon na it should be silicon only, surrounded by the atoms, so it should be silicon only. And for the germanium na it should be surrounded by the germanium atoms only. So this is for intrinsic. Okay, milk mari it should be in pure condition. Okay, so let us now go for the extrinsic. If a milk la you can add it one drop of ink. Okay, what will be the appearance if you added the one drop of ink? Okay, or some drops of ink, what will be the color appearance after adding that ink? It becomes a in a color of appearance we can see it. Yes, it is blue, right? So simply or intrinsic pure semiconductors order we are added with some impurities. Okay, so coloring mari we are just added with the impurities. Add panno abdina it becomes a impurity semiconductors or extrinsic semiconductors, right? So that is the concept. So the extrinsic semiconductor, if it is called it another name is it is the impurity semiconductors. Abdina what it means, if the intrinsic semiconductor is added with the impurities. Added with the impurities. Okay, இப்ப நம்ம சொன்ன இல்லையா colors. So here for our example we are take it, it is milk and here it is the ink. Okay, so here ink எதை மீன் பண்ணுது அப்படின்னா நம்மளோட impurities மீன் பண்ணுது, right? So the appearance it should be that is a blue color னு சொன்னீங்க, right? So the color appearance it should be like our blue color. So இது ரெண்டையும் we have to add அப்படின்னா readily we get the extrinsic semiconductor. Okay, so intrinsic abdinave enadhu milk it should be in a pure form, right? So simply we are we are keep in mind that intrinsic semiconductor if it is nothing but it is a pure semiconductor. If when a pure semiconductor is added with the impurities, automatically it will be converted into a extrinsic semiconductor. Okay, that is the concept. Okay, so in the process okay, by the way of combining the intrinsic semiconductor and impurities, we can name it as a doping. Okay, what is the name? It is nothing but doping. So doping, which is nothing but the process of adding impurities. Okay, very good. Then the impurity atoms நம்ம என்ன சொல்றோம் அப்படின்னா dopants. Okay, so dopants, which is nothing but impurity atoms. Okay, so in that extrinsic semiconductors, okay, the carrier concentration value, it should be multiplied by both Ne and NH and take it as square value. Okay, so value impurities add panna the carrier concentration of the value, it should be increased. Okay, so every times increase na square times நம்மளுக்கு it should be increased. So the formula என்ன அப்படின்னா Ni square should be equal to Ne into NH. Okay, so impurities add panna carrier concentration எனக்கு நம்மளுக்கு என்ன ஆயிட்டே வரும், multiply ஆயிட்டே வரும். Okay, it should be increases. So here for the extrinsic we are using the formula for the carrier concentration. It is Ni square is equal to Ne into NH. Okay, so here Ne, small ne, okay, small ne represents what? Ne எதை represent பண்ணுது? It is number of electrons represent பண்ணுது. It is number of electrons represent பண்ணுது. Okay, and here NH, which is nothing but is the number of holes represent பண்ணுது. Then Ni, which represents the number of intrinsic, okay, intrinsic carrier concentration. So carrier concentration, it should be represent. Okay, next one, we can go for the types of extrinsic semiconductors. Eccentric semiconductors, we can have two types. Okay, one is N type. N type semiconductors and P type semiconductors. So carefully watch it, the types, children. Suppose for the theory part அப்படிங்கும்போது you have to answer when you are known the answers only, known the concept only, you have to answer this one. Okay, problems is not a problematic. Okay, so problem ஒரு பெரிய பிரச்சனையா இருக்காது, நம்மளுக்கு எல்லாரோட வேல்யூஸும் they are given. Okay, so values இருந்து நம்மளுக்கு formulas தெரிஞ்சது அப்படின்னா நம்ம ஈஸியா சப்ஸ்டிட்யூட் பண்ணிட்டு ஆன்சர் போட்டுட்டு போயிட்டே இருக்கலாம். பட் தியரி கொஸ்டின்ஸ்ல you should know the concept na மட்டும்தான் you have to answer. கான்செப்ட் தெரிஞ்சா மட்டும்தான் நம்மளால ஆன்சர் பண்ண முடியும், இல்லைன்னா ஆன்சர் பண்ண முடியாது. ஓகே, So இது எல்லாமே வந்து very very simple concepts தான். அந்த concepts கரெக்டா உங்க மைண்ட்ல இருந்தா மட்டும்தான் இந்த questions எல்லாமே தியரி questions எல்லாமே நீங்க அட்டெண்ட் பண்ண முடியும். ஓகே. So this partல இருந்து compulsory we have one theory question. Compulsory I think 3 questions, right? So here for the n type, first one we can go for the n type. Okay, so similarly both of the cases you have to see. Okay, so for the first one here we have to use it the pentavalent impurities for n type. Pentavalent impurities are added. So semiconductors make பண்ணும்போது here they are added the pentavalent impurities. Okay, right. So pentavalent means in numbering la enna numbers சொல்லலாம்? It is the pentavalent. It represented for the number what it is. Pentavalent அப்படின்னா penta means it represents the value, it is 5. Very good. Penta means it is 5. Okay, impurities are added. Pentavalent impurities are added. Here we can have some example, that is phosphorus, arsenic, and SB, antimony, right? And here trivalent impurities are added. Tri means what? Tri means it is yes, very good. It is 3. So for the problems and all, they are given only the examples, or directly they will give you the 3 atoms it should be added. I mean, they are given. So on that time you are keep in mind that 3 it should be represented for trivalent, and 5 it should be represented for pentavalent. So but trivalent na எத்தனை atoms இருக்குன்றது தெரியணும், and pentavalent na it is how many atoms it should be added அப்படின்றது நமக்கு தெரியணும். Okay, so இந்த atoms எல்லாமே நம்மளோட atom structure ஓட cell structureல எந்த locationல it should be added, either valence to cilia or inside the cilia it should be attached. எங்க add பண்ணும் அப்படிங்கும்போது we can make it a n type of material or p type of material. So இந்த atoms எல்லாமே எங்க போய் add ஆகும்? நம்மளோட valence electronsலயா or conduction electronsலயா? Yes, of course, if it is added with the balanced shell. Okay. So here our atom shell is there. Okay. The outermost shell, we are named it as a balanced shell. So the atoms which is present in a balanced shell, which is nothing but balanced electrons, right? So in the 5 atoms for the N type abdina, for the 5 atoms, the outermost shell la dhaan namalukku poi enna agum abdina add agum. Okay, so for the 5 atoms you add pandra process ku what it is named, adukku enna name kudukalam namba, and the process of adding impurities to the semiconductors, we are named it as a doping. Okay, so the process name enna, it is doping. Okay, suppose 5 atoms, it should be attached in the outermost shell abdina, we are named it as a N type of semiconductors. Okay, suppose 3, it should be added in the balanced shell abdina, it is a P type semiconductors. So in the my P type, N type, it should be combined. Next, we can go for the example of P type. P type, it is B, Al, and In. Beryllium, aluminium, and indium. So this is the example of P type semiconductors. Yes, very good. Next, second point for both of them. Okay, either you put the separation. So simultaneous are rendukum number points paatharlam. Okay, so here number of electrons, it will be maximum. Okay, so for the N type la, so this is for N type. And this is for P type. Okay. First point already left. First paathache. For the second point, number of electrons or the value, it should be maximum. Okay, electrons value, it should be maximum. The majority carriers will be what? It is the electrons. Okay, so N, H. Okay, so simply we are writing the third point. Here, the majority carriers are electrons. Okay, and one more here, minority carriers, which is nothing but here it is a holes. Okay, holes. So similarly here for the second point, the number of holes will be maximum. Inga for the P type, number of holes will be maximum when we are comparing to the electrons numbering. And third one, the majority carriers. So for the P type, majority carriers is another, it is a holes. And for the minority carriers, here the minority carrier is electrons. Okay. So that is the difference between the N-type semiconductor and P-type semiconductors. So the 4 points are very, very important. Okay, it is clear. It is clear to all. So I have given it in one clue. Okay, for N-type, N-type. We have to spell it the electrons, ins, electrons, N-type. So it will be majority carrier. So majority na number first larger value da nama paapom, right? So by N value, spell pani parunga, electrons, ins. So it is a N type. So majority carrier la electrons will be maximum. So இப்ப அதுவே ஆப்போசிட்ல என்னவாதான் இருக்கணும், ஒன்னு மைனாரிட்டி கேரியர்ஸ் டிசைட் பண்ணிட்டோம் அப்படின்னா நம்ம ஃபேஸ் பண்றதே இந்த எலக்ட்ரான்ஸ் அண்ட் ஹோல்ஸ் தான் நம்ம டீல் பண்றோம், ரைட்டா? சோ எலக்ட்ரான்ஸோட வேல்யூஸ் இட் ஷுட் பி மெஜாரிட்டி அப்படிங்கும் போது ஆட்டோமேட்டிக்கா the minority will be holes. ஓகே, சோ இதுவே ஜஸ்ட் ஆப்போசிட் தான் என்னது நம்மளோட ஹோல்ஸ். ஹோல்ஸ் பாக்குறோம் அப்படிங்கும் போது ஹோல்ஸ் இட் இஸ் நத்திங் பட் இட் இஸ் a positive p. ஓகே, positive p. So அதனால ஹோல்ஸ் ஓட வேல்யூ இட் should be maximum. Positive p அப்படிங்கும் போது ஹோல்ஸ் இட் represents the positive. Okay, so majority carriers என்னவா தான் இருக்கும், it is the holes, and here the minority will be it is the electrons. இது சிம்பிளா ஞாபகிக்கிறதுக்கு. Okay, yes, it is easy. Today Tamil medium class upload to YouTube. Okay, the Tamil medium it should be from the morning itself. They are finish it off morning 7. Okay, you just go and check it the channel. They are already uploaded. Okay, yes, one more thing, you should put a table. This is for N type and this is for P type. Majority and minority. Okay, you just split it the spacing. For the N type majority value it will be electrons, right? So automatically electrons போட்டுருங்க. So here holes, அவ்வளவுதான். Yes, it is easy. Okay, next one. We can go for the question which is related to the completion of the topic, and if it is asked in a previous year Neet. Okay, Neet question. 2013. In N-type semiconductors, which of the following statement is true? Okay, so here A, which is nothing but holes or minority carriers and pentavalent atoms or dopant. So this is the first option, and for B, holes or the majority carriers and trivalent atoms or dopants. Second one, and third one, electrons or majority carriers and trivalent, and D for electrons or minority and pentavalent atoms or dopants. Okay, இந்த மாதிரி 4 options கொடுத்து choose பண்ண சொன்னா கரெக்டா உங்களுக்கு choose பண்ண தெரியணும். If you know the concept na, readily you have to mark the answer. சொல்லுங்க பார்க்கலாம். What it is for N type. Okay, so N type, N சொல்லிருக்கமா. What will be the majority carrier? In sound, electrons in. So which will be the majority carrier for the N type? It is electrons, right? So simply electrons ku poi parunga. And here for the third option, it is right for the first half. And here they are provided trivalent, so it is wrong, right? And similarly, inga ponga, இதுவும் it should be wrong. So இப்ப இந்த ரெண்டு பாட்டும் காலி பண்ணியாச்சு. Next, and here it is a pentavalent வரணும், so it is a trivalent ன்னு வந்திருக்கு. So இப்ப option first போங்க, it is holes or the minority carriers. Okay, it is in N type, and here it is a pentavalent atoms. Okay, N type la 5 தான் இருக்கும். Okay, so it is a 5, the condition satisfied, and holes, it is a minority, right? So the option A is the right one. Okay, up to this clear? So it is clear to all. நீங்க பார்த்த the concepts எல்லாமே all are very clear. Comment பண்ணுங்க பார்க்கலாம். Yes. Okay, very good. And two more examples and related problems is there. Okay, so this should be continued in the next class. Okay, so for the next class we are started with the new topic, right? Okay. Thank you for your cooperation. Thank you, children. Meet you on tomorrow.